This is data analytics for accounting, Lab 6.1 using generative AI to evaluate trends and outliers. In this lab, we're going to review purchase card transactions for outliers and audit anomalies and use ChatGPT to help us understand this a little bit better. As with most of these things, before we start analyzing data, we want to understand what it is that we're looking for. So our first prompt is going to ask, what are some anomalies an auditor would look for in purchase transactions? This should give us some common ideas for us to think about as we're doing the analysis. So red flags or anomalies might be unusual patterns, so unusual vendor activities, for example, duplicate payments, missing documentation, timing irregularities, and your results will come up probably in a different format because generative AI is going to generate different results each time. But the main categories should be consistent. Authorization issues, split purchases when we're trying to get around thresholds, round dollar amounts, and so forth. So it looks at a couple of these transactions. And now that we have these, we'll start analyzing some data. So we're going to attach our data file. This is Lab 6.1 GenAI data. And this is using data that's already been converted to the audit data standard. And what we want to do is we want to filter these transactions to only show OSU transactions. If we run this, we should get a filtered list that is going to filter this on the business unit description equals Oklahoma State University. ChatGPT should be able to infer the OSU as Oklahoma State University, but if it doesn't, you may need to tweak this prompt to get a little bit better. Here we are. To filter the data set, we look at business unit description, keep only the rows where the value is Oklahoma State University. So it was pretty good at guessing what we had here. Now that it's filtering the rows, we have about 10,115 transactions. And here is Python code that you could use to replicate that filter if you wanted to. You could also do it in Excel if you needed to. Now that we have this, we want to understand the data. So our next prompt is going to ask us to describe the data structure and tell us how many people made purchases during this period. So looking at the output, it's going to say that we have about 38,000 transactions. 10,000 of those are OSU. It's 12 variables. So it's going to give us a data dictionary, describe what is found in each of the columns, how many people made purchase, and then we can find some different items here. Now we're going to start working with the analysis. For our next prompt, we want to create a horizontal bar chart showing purchase order amount by supplier. And we can overlay a color scale based on the count of purchase orders in addition to the purchase order amount. Now, because this last prompt did not focus on the OSU data, we may alter this to say, focus only on OSU transactions. So this is going to take a little bit of thinking to create this chart. We'll let ChatGPT do its thing for a moment. Depending on how many people are accessing these systems, it may take a little bit longer than normal, or if it's using a higher level model to do the analysis. If you're curious to see what's going on, click on the analyzing down arrow, and you can see that it's generating Python code to filter out the data, to create a data frame here, aggregate the values, and to generate the plot that it's going to present for you. All right, so now we have OSU purchase order amount by supplier, and we can see the suppliers here. As the color goes from purple to yellow, yellow represents lots of small transactions. So these purple ones are larger transactions compared to a whole bunch of little purchases from Lowe's, for example. And for the hotels here, we have transactions of relative size. And again, you have a description here of how this looks. Now that we've done that, let's create our second visualization. And we're going to create a line chart showing purchase order amount and the count of purchases by day for the month of September, which is what our data set is presenting. Again, if you expand the analyzing, you'll see the Python code that it's pulling in order to evaluate the transaction. Okay, and here we can see the purchase order amount as well as the purchase order count, which is not a terribly useful metric on this scale. If we wanted to fix this visualization to make it look a little bit better, then what we could do is analyze it to show different scales for those transactions. So let's filter this a little bit more with a follow-up. Focus only on OSU transactions. And in this case, use a different scale for each value. Now we have a visual that's a little bit more useful. We can see the purchase order amount, which has its scale on the left here, and purchase order count, that has its scale on the right. So when our purchase order count is lower, it would show higher dollar value transactions relative to the purchase order quantity. Again, you can refine this by changing the colors to make it a little bit more readable, but now we have something that's more useful. From here, we want to put our sixth prompt in, where we want to create a scatter plot showing clusters of purchasers represented by the entered by and purchase order amount as the y-axis with the count of purchase orders on the x-axis. Label the top purchase orders. And again, because it hasn't automatically filtered this on OSU data, we want to use OSU transactions. All right, so now we have a clustered diagram showing the count, purchase order amount. Most of our transactions are down here in the bottom left corner, but here we have some individuals that represent outliers. These are our purchasers who are making the most purchases or the biggest purchases with the highest quantity. As an auditor, we may be more interested in these ones. And again, it's giving us an overview and understanding of what those outliers represent. It offers an option here, notice, to do automatic cluster detection. So if we wanted to take just the scatter plot and break it apart into clusters, we could do that as well. For now, we'll leave this as it is. One more thing I want to show you is that you can click on this switch to interactive chart, and this will allow you to hover over to specific values and understand where those clusters are. Switch it back to a static and you can see who made those purchases. All right, now we'll continue with prompt 7. We're going to create a table showing the purchase order ID, date, purchaser, supplier, group, and purchase order amount. Again, we're going to use OSU transactions. So not only can we have visualizations describing the data and showing some of these patterns and anomalies and outliers, we can also just create a table that lists each of the different data values that we want to identify. So here we have basic transaction data that we can download a comma separated value file of and do additional analysis. Now at this point, we want to do a Benford's analysis transaction test. So for prompt 8, copy over, finally plot the transactions using Benford's law. And what this will do is this will extract the first digit of each of the transactions and then create a frequency distribution of those digits. Normally in Benford's law, we have a standard predictable distribution of digits. So this will allow us to compare those values and see if there are any values of transactions that start with a specific digit that are outside of the normal bounds of that distribution. Here, the orange represents the expected value, and the blue represents the observed. So we can see 4s and 5s are a little bit higher than what we'd expect, and that may be perfectly normal, but it may be something that we want to identify as an auditor. Here it's showing the calculation, how it observed that, and where it's looking for specific deviations here. Slight deviations appear, but nothing extremely abnormal. So it's trying to help us understand whether those are particularly suspicious. We can do more advanced Benford's test analysis to determine whether it passes from an auditor perspective. Feel free to ask follow-up questions as you work through here. Now that we've done all these analyses, let's put in our 9th prompt. We want to identify all transactions that could represent error or fraud and explain why they are suspicious. A quick caveat, all of these transactions are likely to be normal, non-fraudulent transactions, but the ones that are outliers represent risk, and auditors are especially concerned with identifying risk. This is what the output tells us. They're not necessarily fraud, but these transactions represent some suspicious items. We have unusually large amounts. We have some transactions happening on the weekends. We have round dollar amounts, possible duplicate transactions. So in this case, it's just giving a description of what they are, but rather than analyzing all 2,336, we can follow up with a question, say, let's look at the most suspicious transactions ranked by risk score. So we can just say, yes, please. You could also more specifically put in the exact prompt for identifying 20 highly problematic transactions. All right, so now we have the 20 most suspicious transactions that are being paid here. And it's telling us what the risk score is, whether it's a large amount, a weekend purchase, so all the different analyses that it triggers. And then it talks about why these would be interesting to the auditors. For our 10th prompt, we want to ask, let's suggest some courses of actions to investigate and follow up on these specific transactions. So now it would say, all right, Go and check these transactions, confirm the vendor is legitimate, purchase orders have the data, investigate duplicate transactions. And again, it's telling us why we should care about these. This all ties into what it presented at the very beginning on what auditors should be looking for. But now we're getting into a little bit more specific detail. And as we talk about frequently, these data analytics do not prove fraud. They simply identify transactions that should be investigated, looked at close. Now that we've done this, let's go ahead and summarize this with our prompt 11, our final prompt. We want to summarize the key anomalies from this data for an internal auditor, citing specific transactions that are potentially problematic. So now we're looking at the scope. Again, your results are going to be different from this, but they should be generally in the same ballpark. Here are the specific transactions. Why are they concerning? Here we have potential duplicate transactions. Here we have unusually large amounts in the top 1% of all purchases. We have round dollar transactions. Here are the people who are spending the most money. So it's pulling all of these different visuals and analyses, summarizing them into what could be an audit report or could be follow-up for the auditors. Here's what you should do next, and here's the conclusion. If you wanted to create an executive summary, you could follow up behind it. This gives us an overview of how to use these analytics using ChatGPT or other generative AI tools to help understand outliers and anomalies in the data. Go ahead and scroll back up to take your screenshots, answer the objective questions with follow-up questions here, as well as analysis questions. Understand what's going on and try and figure out if you can understand what the AI is doing for you. Once you've done that, that concludes this lab.